Hello, everyone. Welcome to my lectures on IRT physics. I'm Dr. Vijay Singh, and I'm a London-based educator and consultant. Today, I'll be talking on mechanics, and let's start with a mechanics problem. This problem was asked in the IRT-J exam in 1994, and this was a 6-marker question. So let's quickly read the question. You have two towers. You have tower A and you have tower AB and tower CD. So you see this is tower AB and this is tower CD. So you have two towers, tower AB and CD, and they are situated a distance apart. You see they are separated by a distance D apart. As shown in the figure, you see they are separated by a distance D apart. Tower AB is 20 meters high. This is 20 meters high, and tower CD is 30 meters high from the ground. An object of mass M. So here you have an object of mass M that is thrown from top of AB. So this is thrown from top of AB horizontally with a velocity of 10 meters per second. So this is thrown horizontally with a velocity of 10 meters per second towards CD. Simultaneously, another object of mass twice M. So here you have another object of mass twice M, and that is thrown from the top of tower CD at an angle 60 degree to the horizontal. You see, this is thrown at an angle 60 degree to the horizontal, and that is thrown towards AB with the same magnitude of initial velocity as that of the first object. So technically, this mass twice M is also thrown with a velocity of 10 meters per second, because it clearly says that the second object that is thrown from CD has a mass twice M, and it is thrown with the same magnitude of initial velocity as that of the first object. Now what happens? The two objects move in the same vertical plane. They collide in midair and stick to each other. So what might be happening? This might be going like this, whereas this might be coming like this. They both collide here and they stick to each other. You are asked to calculate the distance D between the towers. So you are asked to calculate what is the distance D between the towers, and you are asked to calculate the position where the object hits the ground. So position where the both combined object, they hit the ground. So this question is related to projectile motion and Suvat equations. That's the kinematics equations. So let's try solving this question. I would advise you to pause the video and try attempting this question. Once you have attempted this question, you can reflect on your answer and on your understanding on reflecting my solution. So let's go over the solution now. So you have this tower AB. So let's start from tower AB. So from tower AB, you have the object thrown in this way. So it follows a projectile path. So let's calculate what is the horizontal distance traveled. You know that using the Suvat equation, S is ut plus half at square. What we do is we try to write the equation for the horizontal component. So you have the horizontal component of the displacement is equal to the horizontal component of the velocity multiplied by time plus half times the horizontal component of the acceleration multiplied by time squared. So initial velocity in the horizontal direction is 10 because the stone is thrown horizontally with a velocity of 10 meters per second. So this is 10. Time we don't know. So let's put that as T. T is unknown here. Acceleration along the horizontal direction is 0 because there are no resistive forces acting along the horizontal direction or along the horizontal axis. So the acceleration along the horizontal direction is 0. So plus 0. So that becomes just 10t. Now let's try to calculate what is the vertical distance traveled by this stone or this object. So use the Suvat equation for the vertical axis. So Sy is equal to Uy times t, the velocity along the vertical axis times time plus half multiplied by acceleration along the vertical axis multiplied by time squared. So you see, since this stone was thrown horizontally, its vertical component of velocity is 0. So you can put that as 0. plus half acceleration in the vertical axis is 10. So you have half times 10 times t squared, which is 5t squared. So you have got one set of equations, and this is for AB. Let's try to find the equations for CD. So let's look at the mass that was thrown from the top of the tower CD. The mass was twice m, and it was thrown at an angle 60 degrees to the horizontal. So for CD, the horizontal component of the velocity is going to be 10 cos 60, because this is the angle 60. And if you find what is the horizontal component, that gives you 10 cos 60. So the horizontal distance traveled would be 10 cos 60 multiplied by t plus half ax t squared. But acceleration along x-axis is 0. So that becomes 0. So we have Sx is 10 cos 60t. Now, what about Sy? What is the vertical distance traveled? So vertical distance traveled would be, again, you can use the formula uy times t plus half ayt squared. So uy, the vertical component of the velocity, is 10 sine 60. So 10 sine 60 times t plus half acceleration is 10 times t squared. Sine 60 is root 3 over 2. So plug in the value root 3 over 2. So 10 root 3 over 2 times t plus 5t squared. So you can rearrange this and it gives you 5 square root of 3t plus 5t squared. Now the vertical distance traveled by this mass twice m is this one. Now if you look here, the vertical distance traveled by this mass, let's say it is thrown from here and it goes like this. So what happens, it covers a vertical distance of this. This vertical distance is actually this 10 plus y. Why? Because this is already given. This is 20 and this is 30. So this distance is 10 and this is 10 plus y. So we can say that 10 plus y here, 10 plus y is equal to Sy, which is 5 square root of 3 times t plus 5t squared. So you could say y plus 10 is this. So you have 5 square root of 3 times t plus 5t squared. Now y from AB was 5t squared. So you can sub in 5t squared. So 5t squared plus 10 is 5 root 3t plus 5t squared. You could cross off 5t squared and you would get 5 root 3t is 10, or you would get t is 2 over root 3, which is 1.15 seconds. So we calculated the time at which both the masses actually collide. So the time after which both the masses collide is 2 over square root of 3 seconds, which is approximately 1.15 seconds. Now let's calculate what is the d distance, the horizontal distance between AB and CD. Now the horizontal distance traveled by the mass m that was thrown from AB is actually 10t. This is the horizontal distance is 10t, and the horizontal distance traveled by the mass that was thrown from the tower CD is equal to 10 cos 60t. So you will have 10 cos 60t. So technically 10 cos 60t is this distance that is traveled, and 10t is this distance that is traveled. So when you add this distance as well as this distance, you should be getting this distance. So you will have 10 cos 60t. So 10 cos 60t plus 10t is equal to d. Sub in the value for t. So you will get 10 cos 60 is half, and t is 2 square root of 3 plus 10 times 2 square root of 3. That is 30 square root of 3, which gives you approximately 17.3 meters. So the distance d between the towers is 17.3 meters. So we have solved the first part of the question. Then comes the second part of the question, and that is on conservation of momentum. You know that the momentum is always conserved. So when this mass comes here and this mass comes here, the horizontal velocity of this mass and the horizontal velocity of this mass, when we add them together, that's the total momentum of both the masses. Momentum is a vector quantity, so be careful with the direction. So let's try to understand what is the momentum of, or the horizontal momentum of the mass that was thrown from AB. So the horizontal momentum of the mass that was thrown from AB is m times 10, because 10 is the velocity. 10 is the velocity for mass m thrown, and momentum is mass times velocity, so it is 10m. And it is going right, so this is positive 10m. For the mass that was thrown from CD, the horizontal velocity was 10 cos 60, 10 cos 60. So 10 cos 60, and cos 60 is half. So this is going to be 10 multiplied by half, which is 5. And momentum is mass times velocity, so this is going to be twice m times 5. But this mass was traveling left, so that would be negative. So that would be negative 2m times 5. So m1 v1 plus m2 v2 is equal to m1 plus m2 times v. So here you have m times 10, and because this was traveling towards left, so you will have minus twice m times 5, which is again 10m, is equal to 3m, which is the sum of the combined masses. So we have 3m times the net velocity, and you see the net velocity comes out to be 0 because this is 10m and this is negative 10m. So that gives the net horizontal velocity of both the masses combined is 0. This means that the horizontal momentum comes out to be 0. So the combination will stop moving horizontally, but only drop down vertically. So technically these masses, they will simply drop down like this. They will stop moving horizontally. Now we need to find what is the distance. So the point where they hit here, we need to find what is this distance traveled. So this distance traveled would be, let's say from here, if we try to calculate, this would be 10 times t, 10 times t. That's the horizontal distance traveled. So let's say, because this is falling vertically, so this distance here and this distance here is the same. So 10 times t, and 10 times t is 10 multiplied by 2 times square root of 3, which is approximately 11.54 meters. So this brings end to this question. I hope you enjoyed solving this question. Keep solving more questions on mechanics and keep watching my videos and subscribe to my channel. Thank you.